You have chosen answer C. The pressure is less than atmospheric pressure. And indeed, this is correct. Now at point 1, we have little to no kinetic energy and lots of potential energy. So our potential energy is highest at point 1. At point 3, we assume this is our highest point for the energy balance here. Thus, all potential energy has been converted to kinetic energy. So we have lots of kinetic energy leaving. Of course, this assumes that no energy is lost in between the system, that we're converting all potential energy into kinetic energy. But this doesn't tell us about point 2, or how pressure plays a role. Now, if we look at the Bernoulli equation that was derived from performing a force balance on a differential fluid element, we get the following result, in which we have a pressure term plus a kinetic term plus our potential term. And this is constant along a streamline. And there's some other assumptions that go along with it, and we won't go into detail here. The result is 3 components that could be related to the energy. These are actually energy per volume. We have what looks like potential energy, a kinetic energy term, and what we're going to call a flow energy term for this pressure. So thus the flow energy, or pressure, is related to the kinetic energy and potential energy. Since the velocity of the fluid must be the same at point 2 and point 3 due to continuity and conservation of mass, right, we know that the velocity in the area here has to be the same as the velocity times the area at point 3. Since the area of the tube isn't changing, the velocities must be the same. Therefore, the kinetic energy is the same. But the potential energy at point 2 is higher than that than point 3. Thus, since this term is greater at point 2, this term must be lower. So P2 is less than atmospheric pressure. So another question you could ask in this problem is, which direction does the cart move? Well, of course it moves to the left. We have water shooting out to the right. From experience, we could say it moves to the left. But can you show that using a momentum balance? Give it a shot. Check out some of the other screencasts that test this concept.